Chapter 8, Number 91, Assessment Number 11. Alright, so Part A asks us what is the maximum wind speed in which the blowfly can stand. It also gives us a bunch of values which we will use later in the problem. So we start by drawing our free body diagram. This would be the blowfly right there. And this distance right here is between its center mass to its legs. That would be L. This would be theta, L sine theta, and L cosine theta, and here's the weight, and then the force of the wind is pushing it on this way. Alright, so if we apply the equilibrium condition where torque, sum of torques equals 0, we get 0 equals mg L cosine minus Fwind L sine theta, and we'll substitute CAV squared for Fwind. We can rearrange our equation. We'll get mg cosine theta CAV, and we're solving for v because we need to know the airspeed at which this blowfly can withstand. So yeah, it's v squared, so we'd have to square root this entire thing right here. Alright, so Part A also gives us a bunch of values. It gives us a mass of 0.07 grams, which I then converted to 7 times 10 to the negative third kilograms. That gives us gravity. It gives us a theta value. It gives us the C value, which is 1.3 newtons times second squared times meters, -4, that's important. And it gives us the cross-sectional area, which is 0.1 centimeters, or since we need it in meters, so let's convert it. It'd be 1 times 10 to the negative 5 meters per meter second. Sorry, meter squared. So yeah, we plug all these values in for our equation that we had up there, and we'll get 9.50 meters per second. And you can check all these values. They do come out to be meters per second, which are the appropriate values for speed, velocity. So Part B asks us pretty much the same thing, except what happens if it's standing at an 80-degree angle. So we can do the same thing and just plug in all our values. So we use the same values except for the 80 cosine and 80 sine theta. Sorry, yeah, we just replace the theta pretty much. We'll get 3.05 meters per second. Like I said, that's the appropriate units for velocity. Alright, so Part C of the problem asks us, so there's a dog, sorry, hold on. It compares, pretty much, it's comparing a dog's wind resistance to a fly's air resistance, wind resistance, sorry. So it tells us the mass of the dog is still 10 kilograms, and it tells us the cross-sectional area of that dog is 0.03 meters squared. It also says it's at the same 80-degree angle as before in Part B. So yeah, we plug in all our values, and we'll get the velocity equals 21 meters per second. And I said, and like I said, we could check the units, make sure all the units are correct. So it asks us to compare the two values. So what I did was I just took 21 meters per second, the dog's air resistance, divided by the blowfly's air resistance, 3.05 meters per second. It comes out to be around 7 times more. I don't know if it's cutting off the 7 right here, but it comes out to be like 7 times more than the blowflies. So the dog can withstand wind resistance up to 7 times more than the blowfly. Alright, that's assessment number 11. Thanks for watching.